Hello, welcome to another lesson in geometry. Today we are covering section 3.5, parallel lines and triangles. All right, so our review. Identify the part of speech for the word alternate in each sentence below. You vote for one winner and one alternate. So this is a noun. The person who is your alternate is still a person, and a person's always going to be a noun. Okay. All right, so your two friends alternate serves during tennis. This is a verb, to alternate, to switch places, okay? You and your sister babysit on alternate nights. This is an adjective explaining which nights you are going to be the babysitter, okay? Write the converse of this statement. If it is raining, then I need an umbrella. The converse is, if I need an umbrella, then it is raining. Okay. All right, so we have a vocabulary builder here. Try. Try means triple. It's a prefix for meaning three. So you have like a triangle, three sides. Tricycle, three wheels. A tripod, three pegs to stand it up on. All right. Write true or false for each. So a tripod is a stand that has three legs. This is true. A triangle is a polygon with three or more sides. This is not true. This is just three sides for a polygon, so this is false. A triathlon is a race with two events, swimming and bicycling, and this is also false. Triathlon would have to have three events, swimming, bicycling, and running. Okay. And in order to triple an amount, you multiply it by three. This is true, because three times as much would be triple it. All right, let's flip it over and see what's on our second page. Okay, on our second page, we have a postulate here. It's the parallel postulate. Okay, so through a point not on a line, so P is not on line L. Okay, there is one and only one parallel line that can go through P that's parallel to L. So there's only one way to draw a line through P parallel to L. So you can draw one line through P parallel to L. That's it. Only one. All right, our second thing is a theorem, the triangle angle sum theorem. And the triangle angle sum theorem says the sum of the measures of angles of a triangle is 180. And once again, we'll do some work in class to show you why this is true. Okay. All right, so find each angle measure. So this is not too bad. So I know that angle A's measure plus angle B's measure plus angle C's measure is supposed to be 180. And we're given A is 30 and B is 100. So plus the measure of angle C should be 180. So I can subtract those over and see that the measure of angle C is going to be 50. Okay, you could do the same thing for this one. So we know that two of the angles are 45, the third and 90, and the third one we don't know, measure of angle L, but all three of them should add up to 180. So if I subtract 45 and 90 from both sides, I'm going to end up with 45. So this is a 45, 45, 90 triangle. All right. Use the triangle angle sum theorem. So use a diagram at the right. What is the value of Z? So we have to find Z. So we can do this to complete each statement first. So the measure of angle A is 59. The measure of angle ABC. Well, ABC is the big one in this triangle. That's going to be 43 and 49 added together, which is 92. So 43 plus 49, which is 92. Okay. And then the measure of A, which we already know, was 59, plus the measure of angle ABC. ABC was 92, plus the measure of angle Z should equal 180. And that's because the three angles of this big triangle in blue should add up to 180. So then we do 180, subtract 59, subtract 92. So I'm going to pull the calculator out so I don't make a mistake adding that. So, or subtracting. So 180 minus 59 minus 82 makes 39. So the measure of angle Z is 39. All right, so now we're going to try to do it a different way. So we just think of some other way to do it. So first we're going to find the measure of angle BDA. Okay, so the measure of angle BDA, okay, well that's not too bad. We're going to use this little triangle in here, BDA. Okay, so that means the measure of angle A plus this 43 up here, which is angle ABD, plus angle BDA is supposed to be 180. So we'll plug in all the parts. We have angle A is 59, angle ABD is 43, plus we need an X for this one, so we don't know what that is, but it has an X there, equals 180. And when I solve this, I'm going to get X is 78. Subtract 59 and 43 from both sides. Okay. So then in number 16, find the measure of angle angle BDC. So BDC is this red one here. Now the red one and angle X, the one where this X is, are a linear pair. Okay, they form a straight line. So I know that X plus Y degrees should equal 180. Okay, and that's because they form a linear pair, and that means they're supplementary. So I already got X. I got X was 78, plus Y is supposed to be 180. Okay, and then if I subtract 78 from both sides, I get 102 for Y. Okay, all right, so that finishes us up here. So we know that Z, I'm going to put this in, and Y and 49 together should add up to 180. So Z degrees plus Y degrees plus 49 degrees should equal 180 because they form a triangle. Okay, but we already know what Y is. Y is 102. So Z degrees plus 102 degrees plus 49 degrees equals 180 degrees. Okay. And then I can just subtract the 102 and the 49 from both sides, and I'm going to get the same answer as before. Z is 39 degrees. All right, on the third page, we have the triangle exterior angle theorem. So triangle exterior angle theorem. And the triangle, so first off, we have to know what an exterior angle of a polygon is. So an exterior angle of a polygon is an angle formed by the side in the extension of an adjacent side. Okay. So here's a triangle. If I take one of the sides and I extend it, I get an exterior angle. Now it doesn't matter which side you do, you're always going to get an exterior angle. And we always measure the exterior angle, the one that's less than 180. Okay? So for instance, if we had this rectangle or quadrilateral, we could extend one of the sides and we always measure this shorter side. That's our exterior angle. Okay? For each exterior angle of a triangle, the two non-adjacent interior angles are its remote interior angles. So for instance, this one, angle 1 is exterior. This angle right here is adjacent to angle 1, so we don't use that. We use the non-adjacent one. These two are the remote angles compared to this exterior angle. Now it changes as I move the angles around. Okay. So the measure of each exterior angle in a triangle equals the sum of the measures of its two remote interior angles. This is the theorem, the triangle exterior angle theorem. Okay? All right. So in this case, the measure of angle 1 is equal to the measures of angle 2 and 3. The remote ones add up to the exterior one. All right, circle the number of each exterior angle and draw a box around the number of each remote interior angle. So the exterior angles are formed by extending one of the sides, so angle 3 and angle 4. The remote ones are the non-adjacent to that exterior, so angle 1 and 2 putting boxes, and angle 5 and 6. Those are in boxes. Okay. All right, so our first problem about this, use the triangle exterior angle theorem. The two angles of a triangle measure 53. What is the measure of an exterior angle at each vertex of the triangle? All right, so because they're congruent, it's easy to know where to put the 53. We put it where the congruent marks are here. Okay. All right, so label the exterior angles, and label the interior angles 53, 53, and A. Label the exterior angles adjacent to the 53, X and Y. So these are adjacent to the 53s. And label the third exterior angle Z. Okay. All right, so complete the flow chart. 53 plus 53 plus A. That's our triangle sum theorem, because this is talking about the green triangle. The three angles of a triangle always add up to 180. Okay, so that means A is equal to 180 minus these two added together, which makes 106. And then 180 minus 106 is 74. Okay. All right, so I can put a 74 in place of A. Then we can use the exterior angle theorem 3 times to get all of the different exterior angles. So X is equal to A plus 53. The two remote from X are A and 53. Okay. So then we can solve for this because we already know what A's value is. A was 74, so 74 plus 53 makes 7 and 127. Okay. And that makes sense because if we look at this one, 53 and X, those are supposed to be a linear pair, so they should be supplementary. So 127 and 53 make 180. Okay. All right, so our exterior angle, we're going to find Y. Y is going to have exactly the same work because it's using A and 53, sum of those. And we already know what A's value was. It was 74. So 74 and 53 add up to 127 again. And it makes sense because those two form a linear pair. And then Z is going to be a little bit different. Z is equal to 53 plus 53, which is 106. Okay, so Z is, we'll erase all this stuff again. So this is 53 and 53, and Z is right here. So Z is equal to the sum of the two remote interiors, which is 53 plus 53. Okay, on our last page, problem number 3, apply the triangle theorems. Okay, so can you find the measure of angle A without actually using the triangle exterior angle theorem? So if we ignore the exterior angle and the fact that these two remote angles are supposed to add up to it, can we still get the answer? Okay, and the answer, of course, is yes. Okay, we just use our other thing we knew. So here is DCB, okay, and here is ACB. These two form a linear pair, therefore they are supplementary. So find the measure of angle ACB. Well, that's easy. Since they're supplementary, then we know that they're going to equal to, add up to make 180. So this is the measure of angle ACB. And then that means the measure of angle ACB is equal to 100. Okay. Can you find the measure of angle A if you know 2 of the angle measures? Yeah, of course we can, because we can use the triangle sum theorem for this. So we know that, let's see, 30 plus the 100 plus the unknown angle A, which is X, should equal 180. And this is by the triangle sum theorem. It says 3 sides of a triangle should always add up to 180. Okay, so then we can solve this by subtracting 130 from both sides, and we can get X is 50. So how can we skip around this theorem, the triangle exterior angle theorem? Well, we're going to use 2 things every time. So we can use a linear pair, and then the triangle sum theorem. Okay. All right, so as always, pause the video for a second, do the lesson check yourself, and then come back and make sure that you did it right. Okay. Welcome back. So we are asked to do this in our lesson check. Explain how the triangle exterior angle theorem makes sense based on the triangle angle sum theorem. All right, so let's write the triangle angle sum theorem. Okay, that would say that the measure of angle 1 plus the measure of angle 3 plus the measure of angle 2 is 180. And then the linear pair postulate would be talking about this little part of the diagram. So the measure of angle 4 plus the measure of angle 2 equals 180. Now we're supposed to be able to put these 2 statements together to make that, which is the exterior angles theorem. Okay, so exterior angle theorem. So how do they do that? That's what number 27 is asking. How can we make that happen? All right, and it's going to use the transitive property. So if we take a second and we rewrite the first statement, this one up here, we can change this to the measure of angle 1 plus the measure of angle 3 equals 180 minus the measure of angle 2. Okay, and then we can do the same thing over here. We can, in the second statement, we can subtract measure of angle 2 to both sides, and we can write 180 minus the measure of angle 2 equals the measure of angle 4. Okay, so now we have A is equal to B, B is equal to C. Therefore, we can get that last statement here, which says the measure of angle 1 plus the measure of angle 3 equals the measure of angle 4. And we got this using the transitive property of equality. Okay, and this works out great for us because it lets us see that we don't really need this triangle angle sum theorem. We don't really need this triangle exterior angle theorem if we know this guy and the definition of a linear pair. Or we can see that, hey, we could prove the triangle angle sum theorem using, we could prove the triangle exterior angle theorem using the triangle angle sum theorem and the linear pair. So these two together form that guy, putting them together. Okay. All right. So hopefully you know what an exterior angle is now and what the remote interior angles are. So for a triangle, that means extend one of the sides. Our exterior angle is going to be here, and the remote interiors are here. Remote interiors. Okay. All right, so how well can you use the triangle theorem? So there's two of them here. So we have the triangle sum theorem. The three angles should add up to 180. Okay, and we have this one, the exterior angles theorem. That is, this guy should add up to the remote one. So 1 should equal 2 plus 3. And yes, that's not 1 as in the literal sense. So angle 1 plus angle 2 plus angle 3, and angle 1 equals angle 2 plus angle 3. All right, I'll see you in class next time.